What are the peculiarities of Mediterranean cyclones? Mediterranean cyclones on average have weaker intensities, smaller sizes, and shorter lifespans than mid-latitude cyclones over open oceans. Nevertheless, they often produce high-impact weather, and they are responsible for the majority of regional precipitation and wind extremes. Similar to extratropical cyclones, Mediterranean cyclones develop through baroclinic instability. This is a dynamic process that produces an amplification of pre-existent atmospheric waves. They also intensify thanks to diabatic processes as latent heat release in the atmosphere or heat fluxes from the sea surface. However, Mediterranean cyclones are unique due to the regional geography.
What are the most important discovery steps, tools in Mediterranean cyclones? Let me start with our work. I'm not so shy about it because it was the first time using gridded data to calculate frequency and trajectories of cyclones. Why is this important and what happens next to it in the last 30 years? Many other models were applied to study the dynamics of cyclones. Let me explain in a 1 minute why is this so important. It is important because it brings together the weather with the climate. The weather is expressed very strongly by cyclones. But when we have climatology of cyclones, particularly objective climatology that we can study along the years in climate models, for example, or in reanalysis data, this brings the connection, the very strong connection between weather and climate. So I see this as the most important evolution of the last 30 years in the understanding of Mediterranean cyclones, bridging, to do the bridge between weather and climate.
The Mediterranean is a relatively small region characterized by a semi-enclosed sea that is surrounded by mountains and includes sharp land-to-sea transitions. It is in this region of highly complex geography that cyclogenesis is especially frequent, particularly during the cold winter months. In fact, it is one of the regions with the highest frequency of cyclone occurrences in the world. Mediterranean cyclones are influenced by the prominent mountain chains that encompass the northern side of the basin. Indeed, the presence of the mountains favors cyclogenesis in specific locations. A characteristic example is the southwestern side of the Alpine chain where cyclones frequently develop and then intensify over the Gulf of Genoa. Another unique characteristic of Mediterranean cyclones is their potential to occasionally turn into Medicanes. This is a portmanteau of the words Mediterranean and hurricanes. Sometimes Medicanes are also known as tropical-like cyclones. These systems are visually similar to tropical cyclones and often more intense than common Mediterranean cyclones, to the point of attaining hurricane wind speeds. Medicanes are also similar to polar lows, small-scale cyclones that develop over oceans at high latitudes.
The main problem is the difficulty of distinguishing the warm seclusions, which are the last stage in the evolution of extratropical cyclones, from Medicanes. Both are deep warm core, symmetrical cyclone, which can also appear similar from the satellite. Furthermore, the mechanism of development of Medicanes is not unique. Some cyclones are mostly driven by baroclinic instability, which is the main mechanism of development of extratropical cyclones. Other cyclones are mostly driven by strong diabatic processes, that is the transfer of energy from the sea to the atmosphere and heat released by convection. Only the latter cyclone show characteristics similar to tropical cyclones for short period with comparable strength. Unfortunately, cyclones in these two subcategories are not easy to distinguish.
Compared to actual tropical cyclones, the different mechanisms of development are essentially due to lower sea surface temperatures in the Mediterranean Sea compared to the tropical sectors of the oceans, where the temperature reaches the threshold of 26 degrees Celsius to a depth of several meters. Moreover, the limited sizes of the Mediterranean Sea, as well as the large number of islands and peninsulas in the basin, limit the open sea spaces where cyclones can develop. So, they move without losing contact with the sea only for a limited time, and the inevitable landfall reduces their energy. From a historical analysis of Mediterranean cyclones, the areas most affected by Medicanes are the Ionian Sea and the region around the Balearic Islands. On average, 1.5 Medicanes are recorded each year, primarily during autumn and winter. In fact, autumn is the period with the highest sea surface temperatures and the first cold air intrusions from high latitudes. This temperature contrast triggers favorable conditions for the genesis of these phenomena.
I would say that Medicane Ianos that developed in the Ionian Sea in September 2020 and hit western Greece gave us a glimpse into the future, meaning that more and more scientific studies show that in a warming climate, Medicanes are going to become stronger, even though their frequency of occurrence will remain quite low. With more than 190 kilometers per hour wind gusts and more than 600 millimeters of daily accumulated rainfall, Medicane Ianos can only be compared with Category 1 or 2 hurricanes in the Atlantic.
Several studies based on the analysis of climate model simulations reached a rather general agreement about the future evolution of Medicanes. While their frequency will not increase, their intensity will. Thus, ongoing climate change may exacerbate the already severe characteristics of such phenomena.